Welcome to a new test and teardown video. This time it's a Philips PW9501 conductivity meter. And this one is quite rare to see some stuff like this in my video collection, because this one is a scientific equipment, analytical chemistry. So the idea is you can measure, of course, the conductivity at a special temperature. So there's a temperature sensor, and this sensor calibrates or compensates and handle the conductivity in all sorts of liquids, all sorts of chemistry experiments. And this tells you, of course, the salinity or whatever kind of stuff you got in this solution. And then you can measure what is going on with this. I can't really demonstrate this unit because I don't have the temperature sensors or the special probes you need that has the exact sizes and dimensions and the distances and all those kinds of things that is definitely needed for this to work. But it's just super interesting to see how is this designed and to what quality level, of course. There's another real funny thing about this number. So the PW9501 from Philips is also the name of a remote control for one of their television sets. So that will cause some sort of Google mix-max. Here at the back, we can see a quite modern IEC connector. Extra grounding, not just this one. Oh dear. We got some 100 millivolt reference. Is this input or output? I don't know. And here we got a 100 ohm, probably some sort of a temperature sensor. And we can also see the type number is -01. So this is the first release of this instrument. After a long time of Googling around, I mean, more or less the only thing I could find was an old sales flyer from Philips. And if we zoom in a little bit on this sales flyer, I think you should probably hit pause right now and just read the text and then think what you feel about this. I don't think this is how they would have done this today, but it's still a really fun sales flyer. So that's why we need to have it right here. Let's look at this absolutely nice detail here. Let's move the lamp a little bit. So this one here is really cool. So you can turn this. Okay, but look up here. If I push it, and then I can change the dial, and then I can move some more. So it locks here, and then push, and then I get some more. That is some kind of cool. All the other knobs, they seems to be rather normal. Yeah, no big deal. And here's the inside details of exactly the same knob. So see, when I dial it, it's just the switch, but when I push and turn it, it's the whole switch I move around with. But it doesn't really seem to have any kind of electrical, I mean, there isn't any sensors or any switches, nothing here. So it is only a helper for the readout of what is going on, and there's a mechanical lock that prevents the knob from going. So this is a readout kind of thing. I totally love it. We got, of course, high precision resistors. If we look at a little bit closer, this is 0.25% resistors. is it easy to read right there. And yeah, that is some nice resistors. The rest of this unit is just beautiful, super high quality. I like the way that everything is done in this one so far. I haven't seen anything to complain about, really. It is a little bit over what I see in an average Philips when it comes to manufacturing. I mean, look at that. Everything is just crazy. That many? Why? What if, I can't stop laughing of this. I mean, so the wires goes in here through the hole, and then they are bent around and comes up through another hole and then soldered. Of course, this is so you don't get any kind of stress in the solder joint. Brilliant thinking. And this switch down here, there's a little ceramic holder for the resistors involving this switch. And a little configuration switch right there. Look at that one. To do a little bit of flip-flop some phases. That will be some filters for the power supplies or something like that. Special components. It's full of modern transistors for that age. How old is this? I have no clue yet, because there isn't any information online to find. I'll hopefully be able to. Those are. Yes, inductors. Here is the circuit board design. I think down here we'll have some of the power supply. Look at the ground. So I believe this is a common ground or some common power supply that is important. So this is why they have those parallel tracks from that going to different parts of the circuit. So all that is fine. A little bit of a modification right there. This unit was definitely stored a wet place, so the aluminium is corroded, and I can start to see some sort of signs on the circuit board as well. So this is probably not so good. So I'm trying to figure every little detail in this unit. They're not using regular banana plugs, they're using some high quality shielded ones. That is a little bit special. And I think this is a Teflon or some special low leakage material. Feels and looks special, and they're nice to show how to reconfigure this for different mains. There's probably a little power supply in here as well. So let's open that one. But first I want to show this funny little detail. Here there is a switch where you can select different earth or earth lift. And this one was supposed to be screwed into those two holes, but as you can see here, somebody stole the screws. So that is a little bit annoying. A nice ceramic thing where all the different groundings go to this common star point of earthing and grounding, and then you can connect them together in one point. This is like typical medical craziness, maybe, or just rules and regulations. I just rotated one of those capacitors here in the mains filter. That was behind this nice little shield box made of iron, so it's really heavy. And this date code is 6804. I don't think this unit is from 68. I mean, it can it really be that old? But this capacitor is manufactured in 68. Don't you just like this filter? So mains goes into the fuse and then into a shielded cable. But look at those thin wires. Is this really rated for kilovolts? And then the shield goes to this point right there. And this wire, of course, goes to the mains on-off switch and comes back here to the filter. Isn't it a little bit funny how the filter is after the switch and not first? So that mains high frequency noise is allowed to travel through the cable and all the way back and then filtered. We got some resistors in series with the incoming signals. Right, I don't know if that is possible to see, but how can I show that? But yeah, here we go. We got some resistors. Somehow they figured that we go here and then they are connected together. But anyway, the mains output goes to the red and the yellow and then all the way to the transformer mains input. And now this picture here is rotated, so it's a little bit confusing. If they rotated this to the left, it would be much more obvious what is going on. But that's just my humble opinion. Other than that, Philips is normally known to be really smart and good, but that was just one tiny little thing. There's also another little date code on the back of the meter, and that is also a classic place for date codes. But here it says 836. So I think it's 83. And this looks a little bit more like what I see here. It could definitely be 83. But in 83, wouldn't it be full of op-amps? But there are no op-amps, only transistors. So maybe this date code is wrong. Maybe it's me who's reading this wrong. So, well, I don't know what to do more about this unit other than just enjoy how beautiful it is designed and manufactured. Like I said earlier, I can't do anything with this one. Just too bad. But it was fun to see the level of this design anyway. So that was just a super short walkthrough of this one. If you have any kind of information about the date, age, release codes, or dates, I don't know, whatever you can find, I will definitely be interested in hearing about it, because I find absolutely nothing. It's totally secret, this product. So thank you very much for watching. Hope to see you soon again. Bye bye.